Hi there and welcome to this video for Senior Physics on electrostatics and electricity. In this video we're going to look at the concept of power. Now basically power talks about the amount of energy that is released by a specific appliance, and each appliance will have its own power rating. And this tells us how much energy they give out of the desired effect that we require. Now often you'll see an appliance which will have an energy rating which is similar to the image that you can see on the right hand side here. Works on a star system, that basically the higher the stars, the more efficient the appliance is at delivering certain amount of required energy. For example, you may see it on a fridge or on a washing machine or a dishwasher, and basically if the higher the star rating, it'll mean that you'll get more available energy in the desired effect than you would with a lower class appliance. Often you'll see the amount of energy consumption per year, and you can see that it's sitting at 670 kilowatt hours per year is the amount of energy that it would use on a regular usage. So how do we utilize power? Well, basically power is the amount of work that is done by the appliance to convert electrical energy into our desired form. Now this may be heat, it might be motion, it might be a variety of different things. So as a result we get an algorithm which you can see down below, where power equals W divided by T, where W is the work done in joules and T would be the amount of time that it's taken in seconds. So power can be classified as joules per second. So power is given the symbol or the unit watts, okay, W-A-T-T-S, and 1 watt is equal to 1 joule per second. So in order to calculate the power of an electrical appliance, we need to generate the same units in joules per second. So we can convert joules per second. So you may get a question along the lines of so many joules occurred per second or per minute. You then need to convert it into seconds, and then you would write your power in the form of watts. And this can be done using an equation which you can see down below, where power equals the voltage times the current. Now voltage, remember, is in joules per coulomb, and current is measured in coulombs per second. So you've got joules per coulomb times coulombs per second. Well, the two coulombs cancel out, and as a result you end up with power being joules per second, and that's where the units come from. Now the units basically are then converted into the form of watts. So in order to utilize this equation, what we can then do is rearrange the resistance equation, V equals I times R, and we can come up with two extra equations which are quite useful for calculating power. So in the first case I can substitute in for I, where I is basically going to be made up of V divided by R. So I get power would equal V times V divided by R, so put the V's together, so I get V squared over R. Or I can substitute in for V and get an equation where I get V equals IR, which would mean I've got I times R times I, so hence I get I squared times R. Now these are good other equations that I can utilize with my circuit, incorporating resistance, current, voltage and power. So be aware of those and make sure that you're clear. So let's look at a quick example. Here I've got a example where I'm going to calculate the power rating for a light bulb that is working off a 240 volt supply and is working at half an amp. So basically I use my formula, P equals V times I. I know that V is 240 volts. I know I is half an amp. So 240 times half an amp gives me 120 watts of light. So that gives me a fairly good powerful light which is going to be generated, and it allows us to utilize the power equation. Now we also know that power, the amount of power that we utilize is charged for. We get charged at home for the amount of units of energy which we basically are going to be utilizing. Now basically what we can then state is that work will equal power times the time, so the amount of time that we utilize and the power that goes on. Now, often this is written in kilowatt hours, and we have the number of units in kilowatt hours, and that's what we are charged for. So you may have to pay 80 cents, for example, for 1 kilowatt hour. So obviously the more kilowatt hours you utilize at home, the more you are charged. So here's an example where we can utilize cost and amount of power that we utilize as it goes through our house. So if electricity costs 18 cents per kilowatt hour, how much does it cost to run a 1 kilowatt fire for 8 hours? So remember, we've got a fire which is giving out 1 kilowatts and it's been running for 8 hours. So it's fairly straightforward. I use my algorithm for work equals power times time. Now I know the power was 1 kilowatt and I know my time is 8 hours. So the number of units is 8 kilowatt hours. So as a result, the cost will be 8 kilowatt hours times 18 cents, which gives me a total cost of $1.44 to run that fire over 8 hours. And this is how you can work out the cost effectiveness of a system. So for example, you might buy a hot tub, and the hot tub may cost you, they may say, well, it will cost you this amount of cents per day, or you may get a heating system and it will cost this much cents per day. And what they're talking about is the amount of power that they utilize at a standard rate of electrical charges. So this is a very, very good way of being able to utilize power and cost effectiveness in order to run through some various calculations. Okay, well, I hope you found that useful with our talk about power. I have put up an exemplary video where I've run through a more complex power question. Check it out, and hopefully that will help you with any form of power calculations that you may have. Well, thank you for joining me, and I look forward to meeting you again. Bye for now.